All right, welcome. Today, we're diving into a really groundbreaking AI technique coming out of Microsoft research. It's totally changing how we can understand massive, and I mean massive, amounts of information. So let's get right into how this thing works.
You know, we've all seen how amazing AI is at finding specific facts. You can ask it just about anything, and boom, it pulls out a super precise answer. It's like the ultimate needle finder. But what if you don't care about the needle? What if what you really need to understand is the entire haystack? You know, the main ideas, the hidden connections, the whole big picture? Well, that's where things start to get really tricky.
And that right there, that inability to see the whole haystack, it really reveals this huge blind spot in how most AI systems work today. They're absolute masters of the specific detail, but when you ask them to synthesize an entire world of knowledge, they often just fall flat.
Okay, so picture this, the AI search method that most systems use, something called vector-RAG. It's kind of like a librarian who has a flawless, perfect card catalog. You can walk up, ask for a very specific book on a very specific topic, and they'll get it for you in seconds. It is incredibly fast and incredibly accurate for that one job.
And this is where you really see the difference. The system is fantastic at what we call local questions. You know, finding that one single document that tells you when quantum systems bought NeoChip. Easy. But if you ask it a global question, like, hey, what are the major themes across this entire podcast series? It just can't do it. It wasn't built to read everything at once and connect all the dots.
So this standard method has a name, of course. It's formally known as retrieval-augmented generation, or just vector-RAG for short. And the whole idea is that it works by finding these small, super relevant little chunks of text that match your question. It's built for precision, for finding those needles. You know, the actual researchers behind this new technique said it best themselves. Vector-RAG is amazing, but only when the answer you're looking for is tucked away inside just a few little pieces of text. For that big picture view, we're going to need a whole new playbook.
So, if that's the problem, what's the fix? Well, it's this brand new approach called GraphRAG. And trust me, it represents a completely different way of thinking about information itself.
Okay, let's go back to our librarian. If the old way, vector-RAG, is the librarian with the perfect card catalog, then GraphRAG, while GraphRAG is the librarian who has actually read every single book in the library. They don't just know where to find stuff, they understand the content, the characters, the themes, and, this is the crucial part, they understand how all the different stories connect to each other. And that's the huge shift in thinking here. GraphRAG just stops treating information like a long, disconnected list of documents. Instead, it starts to see it for what it really is. A living, breathing network, a web of interconnected ideas, people, and events. It actually builds what we call a knowledge graph. But how in the world does it actually build this incredible map of knowledge? Let's take a look at the process for turning just a messy pile of text into an intelligent, connected network.
It's this really cool four-step process. First, it has a large language model act like a detective. It reads through every single document and pulls out all the key entities, people, places, companies, and how they're related. Then it connects all those dots to build this giant knowledge graph. Next, it gets really smart and organizes this huge graph into communities, which are basically just clusters of topics that are super closely related. And finally, the magic step. It generates summaries for every single cluster, giving you that powerful bird's-eye view of everything.
And what you get at the end? It's just a total transformation. GraphRAG takes this chaotic flood of unstructured text, we're talking thousands of reports or articles, and it turns it into a clean, organized, and deeply insightful map of knowledge that a person or another AI can actually make sense of.
Okay, so this all sounds amazing in theory, right? But does it actually work in the real world? To find out, the researchers at Microsoft put it to the test, a real head-to-head showdown against the old method, vector-RAG. And the results, well, they weren't even close. They were staggering. When an AI judge was asked, which system gives more complete answers, answers that cover all the different parts of a question, it picked GraphRAG 78% of the time. It was a blowout. And it wasn't just about being complete. What about variety? Giving more diverse perspectives and different kinds of insights. Well, when the judge looked for that, GraphRAG was the clear winner again, preferred 75% of the time. It just consistently gave richer, more interesting answers.
But this might be the most mind-blowing part. For these big picture questions, GraphRAG can be way more efficient. We're talking up to 97% fewer tokens. Now, you can think of tokens as sort of the currency of AI, the little bits of words it has to process. Because GraphRAG has already done the hard work of summarizing everything, it has to read a lot less to answer your question, which means it's not only better, it can also be a whole lot faster and cheaper.
So you see, these results are way more than just a cool tech update. They really point to a future where we can unlock a completely new level of understanding from all the data that's just swirling around us every day.
I mean, just think about what this unlocks in the real world. A business could finally uncover those hidden trends that are buried in millions of company emails. A scientist could pull together insights from thousands of research papers in a few minutes, not a few years. An intelligence analyst could finally connect those seemingly random events from a sea of global news. It is a tool for making sense of pure complexity.
So we're finally getting to a point where we can do more than just find the needle. We can actually understand the haystack. And that leaves us with a really fascinating question to think about. What crucial insights, what world-changing connections have been hiding in plain sight this whole time, simply because we never had a tool powerful enough to ask the right, big-picture question?